Hello everyone. Today we're going to be going over the product rule and a way you could sort of visually represent it and make it easier for you to remember in your head, because this is one of the formulas that is not present on the formula sheet if my memory is correct. Anyway, so you may be familiar with the notation that the product rule for saying that, like, if you have a function u equals something x and v is something x, then the derivative of u times v, and here an apostrophe represents the derivative, is going to be equal to u times the derivative of v plus the derivative of u times v. And a more long way of representing this is that duv by dx is equal to udv dx, because it's u times the differential v with respect to x plus v du dx. And what I want to go over today is why this is the case. So imagine you're measuring your function as the area of some rectangle. So the area is equal to uv if this side was u and this side was v. So if you watched the previous video that is on this channel about why calculus notation is the way it is, to find the differential of such a thing, we need to know the extremely small change in the area for an extremely small change in x. And the way we look at this is that for every little change in x, so for every little dx, the rectangle increases in area as u experiences an extremely small change as well. So like there's a bit added on this side, which is du, and there's a bit added on this side, which is dv. And there's also this little square bit here, which has, like, I'll get to why this isn't represented in the main formula later, but it has area of du multiplied by dv. And this part has an area of v multiplied by du, and this has an area of u multiplied by dv. Now, this is for every change for every little dx. So this is our original area, the original value of uv. So when you increment the value of x by little d, you're incrementing the value of uv by v du plus udv plus du times dv, which is this area that's added onto the rectangle here. So initially it might make sense to say that, like, if you're working from basic principles where you have the fx, or rather the fx minus, or x plus dx minus fx over dx, where this is the derivative of something, you would represent the derivative of the product or the area, because of the three rectangles that are added here, duv by dx will be, of course, since this is for every dx, then we have to divide these quantities by dx to demonstrate what the rate of change will be rather than the actual just the change, but more like the rate of change. So you have u dv over dx plus v du over dx plus du dv over dx. Now, the thing is, you might notice that this is different to the original formula. It's similar, but it is different, and it's different in the way that this term is here when normally it isn't. And the reason why this term disappears, so look at this term, like if you look at the other two terms, there's 1d on the top and 1d on the bottom. And this essentially means that you have this infinitely small number divided by an infinitely small number, and you get a reasonably sized number. And the same for this. But in this case, you've got 2d's on top and 1d on the bottom. So even from the perspective of the infinitely small d, or the infinitely small dx, from this guy's perspective, if you say that he was a reasonably sized number, then these guys multiplied together would be infinitely small even from that point of view. It's like infinitely small times 2, if you catch the meaning. So say you had du multiplied by dv over dx, and of course, if you take this part here, it's du by dx, this will be a reasonably sized number. So what's happening here? What's left over is the du divided by 1, and of course divided by 1 really means nothing. It's just du by itself. And du by itself is not actually going to be any significant number when you're calculating duv by dx. So since d means the infinitely small change, since this is meant to be infinitely small, it just goes to 0. Whereas the other ones don't go to 0 because it's an infinitely small number divided by another infinitely small number, which makes a regular sized number. But this is just a regular sized number, which is one of the d's divided by the d on the bottom. And once you have this third d, which is left out in the open, it's on the numerator of the fraction because it's by itself. It's not divided by any infinitely small number. It goes to 0, and the whole expression here goes to 0. So this is ignored when you're calculating the differential of uv. So that's where you get the formula duv by dx is u times dv over dx plus v times dv over dx. And hopefully you can see how this formula here corroborates with the little rectangles that are added onto uv here. And of course, we can kind of shade this part in because we ignore it because it's so extremely small. Alright, so that's all I have to say on the product rule. There will not be examples in this video because I'm just trying to explain where it comes from. Alright, so thanks for watching.